having me here at the conference. I didn't actually know exactly what to expect, so now I have a better feeling for what we're talking about. So originally I was going to talk mainly about the methodology, which I will cover, but I also wanted to start with talking about Udemy in general, stepping back a little bit, talking about how it relates to social good, because it actually has an interesting role to play just by its nature. So I'll talk about that, about Udemy, the marketplace for education, our approach to data science in Udemy, which I think is a little bit unique. We're trying to innovate a little bit on the process there. I'll describe the framework we built. And then I'll go to some initial experiments we ran last year. We launched a new recommender system last year. And then I'll talk about some of the interesting innovations we could do going forwards. OK, so it's interesting that the company was actually conceived, the founder is from a small village in Turkey, Aaron Bali. And so he grew up in a place where he didn't really have good access to education. And so I think it's interesting that the company was conceived as a way for people in anywhere on the planet to be able to access education in an affordable way. And also to enable people who have teaching knowledge or skills to be able to share that with people around the world. And so you can think of it as sort of like Uber, but for education, right? So somehow creating a marketplace which incentivizes instructors to create teaching courses on this platform, at the same time bringing together all these students from different places to access that education. OK, so currently there's about 11 million students at the company. There's more people that are just visiting, but in terms of people who have actually enrolled in some kind of class, it's 11 million. So you can already see that there's certain advantages of scale here. So say the price point typically people pay is around $20 to $30. But because you have so many students, you can actually drive quite a bit of revenue to each instructor. So the top instructors actually can make something like 6 or 7 figures per year. And so actually there's people that just create courses now for a living on this platform. It's just like almost like a cottage industry too, of people, say, who have the expertise in producing the courses. They can partner with like a domain expert and create more courses like that. So I think that's sort of the initial success of the platform. There is sort of a bootstrapping process, so you need to have enough content in a particular language to make it interesting for students to go there and browse and search and find things that they would be interested in learning about. So currently it's mainly English language courses. I think that's about 90%, but half of the students are actually outside of North America. Right? So there's a lot of people from around the world, also in countries where the native language is not necessarily English, but they may also take a lot of these courses. So we are bootstrapping, though, in other languages like Japanese, German, Portuguese, Spanish, and so forth. There's about 20,000 instructors, 40,000 courses, and every month there's something like 2,000 new courses being created. So there's like this continuous stream of courses coming in. The advantage, again, of this scale is that you can have more topical material. So there's some new technology that's just kind of popping up. Then people immediately create a course for that. So when the iWatch was going to be launched, like I think even before that, somebody had already created a course on how do you develop on the iWatch. And so that's an example of the power of a marketplace which is dynamic. One thing I want to mention about the social good aspect, too, is that so, like, for example, like the access to, say, take data science education, right? So one of the speaker yesterday for DataEDGE, one of the basic premises is that the data science resource is scarce, right? So that's why you need to have sort of people, consulting and sort of volunteering their time. The related aspect of that is that the data science education is expensive. Right? So we know that, for example, the program here, I was talking to students like $60,000 for the program for something like 10 courses. But suppose you could reduce that price point down by a factor of 100. Right? So you could imagine on Udemy right now there's a bunch of courses. They're not really coordinated in the fashion of like a master's program. But you could imagine sort of developing the product in that direction and trying to create more interactive courses that are approaching the level of quality that you get with personal instructor or TAs and so forth. So I think that's one of the interesting potentials of Udemy is to sort of make data science or some other kind of education accessible to everybody. And then in that way, you sort of make data scientists less of a scarce resource, right? And that sort of allows social good to propagate more quickly. Okay, so that's the social good aspect of it. So a little bit about how the marketplace works. So we already discussed how as you have more instructors, more courses, then you drive more students to come and look at those courses. That creates more revenue for the instructors, which in turn incentivizes new instructors to create more content and just kind of keeps growing that way. And so the data science part is sort of living on this side here. So because we already have 40,000 courses, when somebody comes to the site, they can't look at all 40,000 courses, right? They can maybe browse 10, 20 courses before they get tired. So that's where the data science comes in as the low-hanging fruit. So in terms of recommendation, search, those kind of classic data science things can be done. And so we're building those kinds of things to allow students to find the content that they're interested in. I think another interesting area for data science at the company, which has not really been exploited yet, is on the learning process. So once people have actually enrolled in the class, we've instrumented in fine detail all the interactions they have with the course material. So we know, for example, every 15 seconds, what part of what lecture they were watching. Did they rewind? Did they pause? We've instrumented all the coding tests. We know exactly what they put into that, how they've responded, how they've done. We know multiple choice, also like the sequence of courses. Did they start in a beginner's course, move on to intermediate, and so forth. And we have 10 million students, so you can also look at aggregates, try to find patterns for learning. And so this hasn't really been fully exploited, but I think it's an interesting data set for doing research on learning science, right? So there's this idea of learning science, but maybe people haven't had that level of data to actually turn it into a true data science. So I think that's sort of one of the opportunities we have here is to actually try to optimize the learning process. And that kind of dovetails with the basic idea of the company, which is to be able to deliver education at scale. And so you would need to have some way to automatically facilitate the learning process. Okay, so the approach we've taken at Udemy is I guess, kind of influenced by my own background. So I was a particle physicist before and also astrophysicist. And so when I think about science, I think about the scientific method, right? So a lot of times people talk about data science and they may equate it with, say, business analytics or statistics or computer science. But another way to look at data science is that the science part could be thought of as an implementation of the scientific method in like a business application, right? So in this case, the main differences are that the cycling times are much faster, right? So like in particle physics, it might take 10 years to build an experiment, collect the data, and do the analysis. But in consumer internet, ideally, you can cycle much, much faster. So it could be, for example, every week. You could imagine actually collecting data after a few days, seeing how do people react to this change of the user experience. Is it better? Is it worse? Maybe some part of it is better, some part of it is worse. You could fix the part that's not working as well, relaunch your new algorithm, and you collect data again. So that's the approach we've taken, is that we think of data science as an experiment cycle, which starts with analysis, which is mostly what people think of as data science. But we think of it also as being able to update an algorithm or configure an algorithm to deploy it quickly. And so I'll describe the methodology we've used to speed up that process, set up the experiments very quickly, and also collect the data and analyze it very quickly so that we can iterate. Another aspect to it is to enable a single person to actually do this whole process on their own. Right? So typically at a company, or at least the companies that I worked at before, at Groupon or at Yahoo, you would have different teams actually doing different parts of this data science cycle. So for example, you might have somebody doing the analysis of the experiment, reporting that to somebody else who is working on the algorithm. So then that person on the algorithm is update their model, or make some change, and then you'd have another engineer that, say, codes that up into the production code base, yet another person, right? And so what happens is that it's much slower when you have multiple groups or people having to hand off this information or to be able to proceed. So our approach has been to try to create a system which allows a single person to effectively do the whole cycle on their own. So this is sort of a little diagram of how we think of it. And so the data science framework is really based on user interaction feedback loops. So we have very fine instrumentation of how users interact with the site. So for example, every course that the potential student sees, we log that. We know whether or not they clicked on it, went and looked in more detail. We know if they enrolled in that class. We know how much they paid for it. We know after they enrolled, how many minutes did they consume. And also we have these pop-up surveys that ask them, would you recommend this course to somebody else? So we have an assessment of how they perceive the quality of that course. So all that data is available to us. And so then we process that data. And then we have some automated workflows that allow us to analyze the data in a deeper way, right? So it's not just that we look at, A, B, was this better, was this worse? We go deeper. So we say, OK, we break it out into different segments, and we say, OK, for these kinds of people, it was a positive effect. For these other ones, it was negative. Or it could be, on this particular web page, we had a positive effect. But this other one, we had cannibalization. It was negative. So we look at all these different breakouts in different dimensions, and that allows us to quickly discern what was working and what was not working. So then that analysis is done, and so the data scientist is sitting here. They look at the data. They also do research on the data, historical data, find what are the interesting features that can predict, say, enrollment rate or consumption or quality. And then they go ahead and create these models. And the model creation to deployment in here, this we use, it's called a PMML standard. So a few years ago when I was at Groupon, I noticed that there was this PMML standard. And at the time, there just started to be some free APIs for PMML. So for example, it's JPMML. It's a Java-based API that's open source. And so I realized that you could actually build a framework which allows you to plug in models using this standard, right? So for example, in R, you can create a decision tree or random forest or neural net, and then it can be described in this XML markup language. Then you have your Java-based library, which can then interpret that in some production system. So the big advantage here is that instead of having to have Java developers to kind of code the algorithms in the production system, which may take, say, a month if you include all the QA and all the staging and these kinds of things because you're changing production code. You just have to create one-time sort of a Java class, which is more abstract. It allows you to plug in this PMML model. And once you've built that, then after that, you can just deploy your models without any update to the production code base. So that's basically the innovation in the process that we implemented here. And so that brought down the time for deployment from weeks down to it's instantaneous. Right? And then the other area where we improve things, I think, is on the workflow side. So here at Groupon and Yahoo, you'd typically have one team that would do the analysis of the experiments and another team building the models. Right, so here we've built one, and they would have different workflows. Right? So it could be that the features you're looking at in the analysis wouldn't even match necessarily the features that were in the model. Right? And so here what we've done is we've just created one workflow. And so when the data scientist creates a new feature to put into a model, that feature is immediately available for the experiment analysis. Right? So that's the other part that speeds things up a lot. And so now, after sort of demonstrating it, and I'll describe the first experiment that we deployed last year. We have three data scientists that we hired, and each one of them is actually able to kind of follow this process now. So I think that was kind of the biggest achievement we had so far, is that we were able to enable individual people to actually go through the whole cycle independently. And in terms of like team building, it's just much more scalable, because now you can assign somebody, say, to search ranking, right? So all the issues related to search ranking, they can handle that and work independently. Or somebody else can work on, for example, clustering algorithms for the courses in terms of topics, and they can just focus on that, implement their changes, and just work independently. Maybe just a little bit aspect here on the dynamic feedback loop. So there's one part is in the model creation, right? So we're using the data to create the models. But a lot of our features are also dynamic. So for example, if you came to the site yesterday, you saw a particular course, you didn't click on it, that's actually one of the features we have. So we incorporate both positive as well as negative feedback. So we know, OK, this person, they've seen 100 Excel courses, they've never clicked, so probably they don't care about that. So then Excel as a topic actually gets suppressed slightly in the ranking function. Similarly, there's promotion for topics that people are interested in. And this is dynamic. So the model may be updated, say, once every month or so. But then these features are actually updated nightly currently. And you can even imagine pushing it further. You can imagine updating the features even almost in real time, right? So we're actually building a workflow like that, so that you can imagine in session. So you start out at the featured page, you're looking at some things, you don't click, you do click, you go up to another page, do a search. When you come back, even in session, within like a minute or so, we could update the ranking function if we have this part of the workflow moving at the level of seconds. And it's actually possible to do nowadays. So, and we're building such a thing. OK, so now I'll move to talking about a specific experiment that we ran last year. This is sort of the inaugural experiment. And so what we did was we built a new recommender system, and we deployed it onto the featured page, which is the starting point for the website most of the time. And let's see. So the way that the featured page is arranged is similar to a lot of websites, similar to Netflix or other kinds of consumer internet companies. And so we have grouping horizontally of the inventory. In this case, it's courses as opposed to movies or something else. And they have some way of grouping that kind of makes sense, right? So they could be in a particular topic, or because you searched for something, or because you clicked on something. There's some association, so that creates a mental model for the user that they're going to be seeing things that are somehow related. And then you can rank these things also. You have these things horizontally. So that's a basic layout. And OK, so the algorithm that we deployed takes a global score. So we have a decision tree. It's a regression tree that's based on personal as well as general features about the data. So it could be, for example, is this course converting a lot of people per impression? Does this course have a high quality rating when people take the course? It could also be personal factors, like when you saw this course last, or a course similar to this, did you click on it or not? So those kinds of features go into the model, and then we create a global score. That global score then we use to create a unit score, right? So the units we think of as groupings, filters on the whole set of inventory. So say we have 40,000 courses. So maybe some fraction of them are related to Excel. Some of them are related to, maybe you clicked on something that was similar to it. So we have these groupings. But then we can also compute a score for the groupings. And the simple method we're using now is just to take the top n and sum up the global scores for those individual courses. And that becomes the unit score. All right, so we do a first pass through all the courses for, say, all the units. We find that the top scoring unit, we put that at the top. Then we remove these courses from the pool to have deduplication, right? And then we repeat this process. And then we get to the second highest ranking unit and so forth. So that's the basic algorithm that we tested out. It turned out to work pretty well. So we got about a 10% lift of revenue across the whole site. But when you dive deeper into the data, we actually got some interesting insights. And so, like for example, on the page where we deployed this change, this featured page, there's about a 15% lift. But what was kind of interesting was that you actually had a lot of downstream effects, right? So if you're just to look at the overall revenue lift, it's 10%. But when you look at what's actually happening, you get some interesting results. Like for example, it might be a little bit expected is that we got actually more searches, even though we didn't make any improvements on search. But what's happening is that when people come to the site, they see more interesting courses, they get more engaged, they end up actually searching more. And so that actually drives up revenue on the search page. Similarly for these kind of topical pages that are related. One thing which I really didn't expect was that we actually had increase of revenue on click-throughs on emails. Right? So this is a little bit harder to understand. And so that'll kind of segue into the next topic. But it looks like there are a lot of correlated effects on the user's path. Right? So say you started on the featured page, you see something interesting, and then maybe the next day you actually pay more attention to an email that Udemy sent out. And so I think this means that you actually have to look at the whole sequence of events to understand the overall impact of any particular change. Right? So maybe that you change the featured page. It didn't have to be that we had an increase in email. Maybe somehow you're cannibalizing from that. Right? So if you don't take those effects into account, then it could be that you think that you're launching something that's improving, but overall somehow the effect is neutral or negative even. So I think this is where things get interesting, and it's important to not just look at this high-level metric, but really dive deeper and understand what's happening in all the different contexts, and also historically, how have you now changed the whole evolution of this user on your website?
So Larry, we've got about maybe 6 or 7 minutes.
Oh, okay. Yeah.
So if you want to take some questions, just bear that in mind.
Sure. Okay, so I'll just close here. So basically, the next steps are to look now at the sequence of actions. And so now we're creating a new workflow that would look at what's the whole evolution across not just searching and browsing, but also did they open an email? Did they watch video? It turns out that the actual sequence is very complex. People leave the site, come back through email, go watch more video, and then it's even more complicated when you consider their whole lifetime, right? So all these sessions, they're kind of evolving. Some sessions might be more watching the video, learning. They may turn then to discovery again. And so actually looking at this whole sequence, we can now consider optimizing what people see when they come to the site. Maybe you want to emphasize more consumption, or maybe you want to emphasize more on discovery. And also on the learning side, you can imagine optimizing even potentially the lecture sequence that they might take. You might emphasize certain lectures more than other ones, depending on how we think they might learn best. So that basically closes the presentation. So data science at Udemy, we think of it as science as being the algorithm experimentation with user interaction feedback loops. And we started out with search and recommendation as the low-hanging fruit, but we'd like to evolve into really doing learning science, where we're looking at the whole path of the user as they're learning and optimize that.
Okay, great. Larry, thanks very much. Okay, I have a hand shooting straight up here, so we've got time for probably 2 or 3 questions, and then we'll break. Yes, sir.
Yeah, I have a 2-part question. The first is a question, the second is a comment. If time permits, I'll get to my comment. So the first question is, you mentioned you were an astrophysicist and a particle physicist by training. For someone who was bitten by the string theory bug many, many years ago, I can fully relate to it. Then I opted for a brand of physics where the probability of staying hungry is less. But anyway, the question is, in experimental particle physics and astrophysics, one of the disciplines or things you learn is ability to pick up signal out of noise, right? A particle physics invention is what? You need a 5 sigma level of statistical significance, right, to call it an invention. Now, can you give me a specific example where your training as a particle physicist or astrophysicist helped in developing models and algorithm in your current stream of work? Very specific example.
Let's see. I think it's hard to find a very specific example, but I think generally speaking, the training you get in the natural sciences, not just particle and astrophysics, but also like chemical modeling or in biology. I think when you get training in the experimental process, how do you look at data in a critical way? Trying to see, is this data good data? Is there a problem with the data? Understanding how do you do a statistical analysis that's valid? Making sure that your control is truly controlled, it's not biased. That kind of experience is actually hard to find in general. And so I think that's probably the biggest value add. And actually, in terms of recruiting, it's actually very hard to find people with those qualities.
So I'll get
and let me check, and you were right, if there is enough time. So let me check another couple of questions, and we may well come back to your comment. OK, thank you. Right down in here.
Really appreciate your presentation. You mentioned that very key part of this is segmenting your users based on either their live stream activity or other. And can you touch base in that? Like, how do you build that segment and how do you maintain that? That's basically the core of all websites that involves a user, I think.
Yeah, so we segment both by the user, but also in terms of other features which are not segmentable by the user. So for example, if you consider when the user comes to the site, they saw the featured page, they did search, they came back in through email. So I think it's not just looking at the segmentation by user, but also it's across many other kinds of dimensions. It could be how many high-quality courses did they see, how many low-quality ones did they see, what was the position of the unit, of this particular unit on the page. So we have actually dozens of features where we break out the data. And then in our analysis tool, once it's implemented, each feature, then it just kind of adds on, and we can sort of just click and then sort of break out the experiment data along that new dimension. So I think that's where it scales pretty well, because otherwise, you'd have to do an ad hoc analysis each time, right, which would take forever. But in this case, we've got it all built in, and you can see the statistical significance along each segment, and then that allows you to figure out what's working and what's not working.
Okay. Let's take a final question here, and I'll come back to you, sir, for your round-up comment. One right in here. Thank you.
Hi, Larry. Thanks for the talk. Just one question. You mentioned about the dynamic ranking algorithm that you use. So is there a version of that that you use for, say, pricing of the courses and also potentially for the revenue share percentage with the instructors?
We've thought about that. I think right now we're not going in that direction. It's looking more like, you could think of it more like an iTunes type model where you want to have a little bit more standardized pricing, just so people understand what the value is of this course, because people don't really know how much should I be paying for an online course. So just try to remove that kind of uncertainty out of the decision-making process and let people focus more on just, what is it that I want to learn? Because that's sort of the key for our business proposition, is that people, they're using the platform to actually continue to learn and use that as a tool to empower themselves and have a better future.
Thank you.
Okay, thank you. All right, do you want the mic again? Very quickly.
Yeah, I'll start with a disclaimer. It's not nice. B, it's tongue-in-cheek. Last time, astrophysicists and particle physicists made a beeline for Wall Street to become quants. They brought the world economy down. So I'm seriously worried, now that they have turned their attention to data science, what they are likely to bring out. The internet? I don't know.
Yeah, in fact, that was the reason why I brought that up yesterday during your panel, is that I don't think it's obvious net that what we're doing is necessarily beneficial for society. You can imagine we didn't really discuss military applications, but I'm sure people are working on that. But on the other hand, like with, say, nuclear energy, it's much easier to control because it has to be in some massive facility. In this case, it's, just shotgun across everything. So I don't know exactly how we can sort of handle that. But I completely agree with you. Like a lot of particle physicists have gone into finance and stuff. On the other hand, like it's not everybody. So like for me, I focus more on like consumer internet, which is a little bit more fuzzy. But I actually think Udemy is a great area to apply data science because in principle it helps people improve themselves.
All right. Larry, thanks so much. Thanks, everyone, for your questions.